So today we will start with the overview of ARM instruction set.
Yes, sir. So that's the most difficult part because out of 50 marks, 30 marks were just based on these.
Okay. So first thing, what we will be seeing is data processing. Okay. Is it visible that my texts are?
Yes, sir, it is.
Yeah. So usually the programming parts, right? I'll try to uh, type instead of write because like it will be easy for you to
Yes, sir.
understand. So here, usually we have the address space like two instructions. One is basically move and move negation. Okay. So here, when we say I want to deal with move, so it is something like from one source to destination, right? So source to destination. So it's something like so we saw that like various register sets are right? Like R1, R2, so on. Also, we discussed there is a external memory, right? External memory.
Yes, sir.
So, if you want to move the data from any memory to this R1, or between this register itself, if you want to move any data, then we usually use this move instruction. So, in the move instruction, we have like always the data will be the destination will be registered itself. Okay, destination will be registered. But the source, right? Source, it can be either register or immediate address. Immediate address. So this immediate address, it can be external address or some internal address. So this can be like directly accessing from the address itself. Okay. And move negation is something like whatever the value I have. For example, if I have 0x AA, okay, whenever I am moving from source to destination, what I will do, I will take not of that, not of source. Okay. In the sense now, if I'm moving move not of that, so what will be moving actually? This I'm moving AA, so move not of that, negation of that, what it will move. So in the binary, what it is 0x 1010 and 1010 A.
So why is A represented as 1010?
AA is in hexadecimal, right? Have you gone through that in the digital electronics? You have that hexa to decimal format, hexa to binary. Have you gone through this binary, decimal to
Yeah,
binary?
sir, but like this concept isn't that clear, so still have doubts in why is A represented as 1010?
Okay. So we have that hexadecimal format, right? Hexadecimal format. So we have something called hexadecimal format. In that number actually in hexadecimal 0 to 15, maximum 15. Okay. But like in hexadecimal means like in the format, actually we have to represent in a single character, right? Single character. So if you see here, if I want to represent this 15, this is a two numbers. It is not single character. So what I do, I represent 0 to 9. After that, what I get 10, 10, but like it is in two number system, right? 10 is actually two numbers. So what I do, instead of 10 in hexadecimal, I represent it as A, 11 as B, C, D, and finally 15 as F. So in hexadecimal format, 0 to 9 as it is, and for 10 to 15, it is as F. This you are clear from decimal and hexa?
Yeah.
Yeah. So now binary, how to convert any decimal number to binary? If I have like 5, how to convert into binary?
So it will be represented as 0, 1, 0, 1.
But how? Actually, you take the LCM
Sir,
method,
I've
right?
actually by hearted the
Oh,
table.
it is actually LCM method. Okay. So
Okay.
2 2s are 4, and you will
4.
get one reminder. 2 2s are 4. One reminder you will get it, correct?
Yeah.
And again, if you divide this,
And then 2 2s are 1, and then
no, 2 1s are
it will
1,
be
2
0.
1s are 2,
Yeah.
and 0 reminder. You have to read in this way. You will get 1 0 1, correct?
Yes, sir.
So same way, if I take A, that is 10, correct?
Yes, sir.
Yeah. So now if I want to divide this, 2 5s are, what is the reminder? 0. 2 2s are 1. So 2 1s are 0. Now how A is
1 0
represented?
1 0.
1 0 1 0, correct? Now here we have
Yes, sir.
AA. In hexa, actually we have to read independently. So if you want to directly convert into binary, individually directly you can convert into 1 0 1 0 1 0 1 0. Hope you got it.
Yes, sir.
Yeah. So now move negation of that means, so we have to move to the destination, the not of that. So not of that is actually 0 1 0 1 0 1 0. So 0 1 0 1 will be moving into the destination. So can you tell me in hexa, what is this hexa? 0x?
Oh, so why is X used?
X, always I represent x as a hexadecimal. 0 we represent in terms of x. 0x means it is in hexa.
Okay.
Okay. But in programming, while programming, if you are
So it will
programming
be
in the
represented as
C,
AA, no, sir.
which one?
No. It will be represented. 1 second.
This is not AA. This is actually 5 5, correct?
Yeah, sir. Yeah.
Yeah. 0x, you don't get confused. So 0x always, I say that, I mean, if I just mention 55, then you will think this is a decimal. So this decimal 55 is not like 0 1 0 1 0 1 0 1, right? So this is something different actually. If you convert this into binary 55, then it will be 2 2s are 1 is a reminder, 2 11s are 0 is a reminder, 2 10s are 1 is reminder, 2 5s are 0 is reminder, 2 2s are 1 is reminder, 2 1s are 0. 1 0 1 0 1 0 1, correct?
Yes, sir.
It is different compared to 0 1 0 1 0 1 0 1, correct? What it came
Yes,
actually
sir.
is 0 1 0 1 0 1 0 1. Here almost it matched, but if you consider like other hexa formats, right, won't match. But it didn't match, right?
No, sir.
Correct, it didn't match. It is here, it is matching actually in case of these 55, but in most of the other cases, right, it won't match this. I mean, hexa and decimal, it is like little different. Okay.
Got it.
Yeah. So that's how actually it moves, not of that value. Hope you're clear.
Yes, sir.
Okay. So when I say actually that addressing direct, so whatever the address you move from the memory to the data direct. But when I talk about immediate, I'll be moving the immediate value itself. In the sense, like if I say I want to move value from one register to the one register, immediately I can say that it had 56 if I want to move, right? So this value I can directly move. Previously, what I was doing, whatever the value is stored in one register, I was moving into another register. But here, I'll be directly moving the value of this 56 into register. This is called immediate addressing. Hope you understood.
Yes, sir.
Okay, so here we can use in this addressing mode R0 to R15, any registers we can use. Okay, and each register size is of 32 bits. 32 bits. Okay. Any doubt here in the data processing instruction?
No, sir.
Okay. Next is actually shift and rotation. Shift and rotation instruction. This shift and rotation, right? It is especially required for your multiplication operations. So, for example, I have number 1010. Okay, so this is nothing but 10, right? 10 in decimal.
Yes, sir.
Okay. Now, if I shift left by one position, if I make 10100, what is in decimal here? This one actually.
So there are 5 digits.
5 bits, but what is in decimal?
10, sir.
No, this is 10. 1010 is 10. So this is reverse.
Then this
right?
will be 100.
No. In binary, it is not the case. So 0 into 2 power 0. Do you remember this? You have studied this now. 0
Yes,
into
sir.
2 power 1 plus 1 into 2 power 2. In calculator directly you can convert. So 0 into 2 power 3.
Yes, sir.
Plus 1 into 2 power 4. So 2 power 4 is 16 plus 0 plus 2 power 2 is 4. Rest all 0, it is 20, correct?
Oh, okay. Yes, sir.
Yeah. So now again I will shift one more bit. So 10. Now you have to try.
So it will be 30.
No. You just try. You do this method and try.
Yes, sir. Try. So it's 80.
No, it's not 80. Actually, it should have been 40. Just check.
So, but
So
2
here,
power 6 is
2 power 0, 2 power 1, 2 power 2.
4.
This is like 2 power 3, correct? Plus 2 power 4, 2 power 5, right? This 2 power 5. Because power starts from 0.
Okay. Sir, I've done a mistake. It's like I started from 1, then
It will
ended
become
up
40.
until 2 power 6. Okay.
Yes. So 2
I
power.
forgot
So
the
if
rule
you
of 2
observe,
power 0.
if you observe one thing, so whenever I didn't shift, it is just 10. And whenever I shifted by 1, left shifted by 1, it became actually the original number, that is, let me consider original number as a, it became 2 power 1. That is like if original number is 10, then 10 into 2, it became 20. Correct? When I shifted to position 2, it became a into 2 power 2. That is original number was 10. 2 power 2 is 4. It became 40. So if I shift again by 3, then it will become 10 into 2 power 3. That is 8. Next, if I shift right, it will become 80. So every left shift will cause the number to be multiplied by power of that. If somebody asks you to implement, I have a number a, then I want to multiply by 8. Then what you have to do? You have to just shift that number by left shift by how much? 3, right?
2 by 3, yes, sir.
Correct. So just left shift by 3 in binary domain. Then you will get the multiplication. So this is actually helps you to multiply. So the shifting operation helps you to multiply. Left shifting is helping you to multiply.
So then how is the right shift done?
Correct. So when you do the right shift, right? So now you have 20. If you right shift 1, what will happen? This 20 will become 10. So every right shift will divide the number. So division can be performed using right shift. Got it?
Yes, sir.
So here there are like some examples given in your notes. So first is move R1, comma R0, comma left shift L hash 1. So here what it is doing, it will left shift whatever the content in R0, whatever content we have in R0, that will left shift by 1, and the result will be moved into R. Whatever the content in the R0 will be left shifted by 1, then result will be moved into R.
So is there any example that can be shown using this?
Yeah, sure.
I mean, like I understood how it's done, but an example would be better.
Yeah, sure. So they have given one example directly. Will not do that. Okay. So now let me consider you have R0 as it has some value hash 9. Okay. So can you tell me like what will be after execution of this? What will be the value of R0? What will be the value of R1? Will R0 change after this execution?
So I'm not understanding how to do the example now. Like I understood the concept of move R1, R0 and all, but this one, it's like...
Okay. So, I mean, I'm saying like initially R0 has hash 9, the value 9. Okay, immediate value
So
usually
the value 9 is 1001.
9 is 1001, correct. And initially, let me consider, so this is the initial before execution of this command. So we have R09 and I have R18. Okay, R18. So I executed this command. So what it is doing, first it will left shift R0 by 1. Correct? So left shift R0 by 1, what will happen?
So it will be 10010.
Correct. It will become 100. But one thing you should remember, it will not change the original value. R0 will remain same, but the modified value of this R0 will be moved into R1. So now R1 will become 10010 and R0 will be still 9.
Okay, got it, sir.
Okay.
Yes, sir.
Oh.
So can we do a right shift also as an example?
Yes. So in the right shift, what we do, move. Let me give okay. So we will take little complex example. So what I will do, I will have in R3, I will have hash 3. Okay, I will have R3 in hash 3. And what I'll do, I'll move R1, R0, right shift logically. Okay. Okay. Sorry. This is logically shift right. This is logically shift left, right? So in 8051 it is sorry. So logically shift right, and I'll say R3. Okay. So you assume R0 has original value 10101. So this is the original value of R0 it had. So can you tell me how it will be like
So it
R1?
has 11010.
Yes, 11010. That is in hexadecimal 1A. In hexadecimal, if you want to convert, it is 1A.
So that time by right shifting, it will be 1101.
Correct. So R1 after
So, but where will it be stored, in R3 or in R1? R3
R1,
mostly.
final result is R1, right? This is the destination. Correct.
So then what's the use of R3?
R3, I am mentioning R3, how much shift I have to do, right? Okay, sorry. It is not 11010. I'm saying in the R3 shift I have to do. I have to right shift by 3. So it is 11010. So these 3 bits will go when I right shift by 3. So it will become just 0011.
Oh,
That is
0011. Okay.
correct. That will be the value of R4. Got it, right?
Yes, sir, got it. So, sir, at the end, if it was just R2, that time the remaining 2 digits, that is 10, would go, and it would be 110. That would be 0110.
Yeah, if it was just a 2 instead of R3 was just a 2, then only 2 digit would have gone.
Yes, sir, got it.
So they have given one problem. Execute 2 into A plus B, this expression. Okay. And they're mentioning A is 2, B is 3. Okay. Can you think how we can do?
No, sir. There's no move instruction. There's no left-right shift. How do we do this?
Yeah. So now initially we have to move this, initialize this value, right? So move A, let me assume that it is stored in R1. B is stored in R2. Okay, this is the initial. So move R1, comma, immediate value, hash 2. Move R2, comma, hash 3. Okay. So now here addition is there. Addition is correct add instruction. Add. We have to use add instruction. And let me say that like I want to store the result in R3, final result. This. So R3. So which one I have to add? B, right? So B I will take. B is actually R2. Okay. Then R3, then R2, then what I will do? 1, right? R1, I have to multiply by 2, right? So multiplication, how I can do? Multiplied by 2. Right shift or left shift?
So left shift.
Correct. Left shift, logically left shift by 1. Okay, so finally here it is. Here I made one mistake. R2 is here. Okay, R2 is here. R2 is here. So R1 I have to logically left shift and then I have to store. Correct. So here, if you see, what will happen? This R1, right? R1 is this one. Logically left shifted by 1. So what will be the value here now?
Oh, 1 second, sir.
Yeah.
So 001.
Which one?
When we left shift
Finally, if
R1
you
by
want to, yeah, we will store in R3. So here R1 is how much?
0001.
No, it is
So
0
since
0
A is
1
2,
0 1 0.
yeah,
R1 is
sir,
0
but
0
then
1 0.
like we have to remove 2 digits.
Left shift, right? Left shift.
Yes, sir.
Left shift is actually add 1 digit, correct? Add 1 digit.
Oh, yeah,
Become
sir.
1 0 0, correct?
Yes, sir.
Yes. So this 1 0 0 it
So
means
it will be
actually this will
4.
become 4, correct? This will become 4.
Yeah.
And R2, what is R2?
Sir, R2
R2 is
is
3.
3, that is 0011. So it will be 0110, which is 6.
No, R2 we should not touch anything. See, this R2 is a location. Actually, see, this is something like first you have to, there is a priority. First you have to do this operation. So you shifted that, right? This is one
Yes,
thing.
sir.
And you have
Okay.
R2. R2 is already 3, that is 0011. Correct?
Yes, sir.
Yeah. So it will add. So you shifted, so it became 4. So you have already 3. So 4 plus 3 will be stored in R3. That is 7.
So 0111 would be stored in add.
0111. Correct.
Yeah, sir. Okay.
This way you have to write the program.
Yeah, got it, sir. So can we have more examples based on this?
Yeah, sure. There are actually 2 more instruction which is pending. Just show you that also. With that, I mean, I'll add. Okay. So I'll give you some of the instructions. You need to tell like what will be the state of registers. Okay. So now move R0, comma, hash 0, 1. So here, which register will be affected?
So
Hello?
move R0, sorry.
Yes. R0, what value it will contain?
So it will contain 0, 0, 0, 1.
Correct. So next, move move n, okay, not move, mvn, move negative.
So how do we
R0,
do the move negative?
yes, I'll tell you. So R0, comma R0. So I said, so 32 bits are there. So all the 32 bits are now 0. And last one bit is 1, correct now? Hello? Initially,
Sir, I didn't
R0
get
was this
it.
value, correct?
Okay, yeah.
Yeah. Now move negative is not of that. Okay? So all the 32 bit now, wherever 0 is there, it will become high, correct?
Yes, sir.
Not is not of that, right? So 4, 8, now it became 16. And last bit, wherever 1 was there, it becomes 0.
Oh, it works as a complement of zeros and ones.
Yes,
so.
yes. Negative move not is actually complement.
Okay, got it, sir.
So it is
So,
actually
but from where did 32 bits come? Like generally we are dealing with 4 bits and suddenly the
no.
32.
So all your 80, 50, all your ARM registers are 32 bits.
So, but the upper problems are solved as 4,
Upper
5.
problem here we have all the MSB bits are 0, right? That's why we are like just representing last bits. I mean, even if it is like 0, 0, 0, 0, 2, if I represent, or like just 2, same, right? That's why. I mean, higher bits are 0. That's why I'm not representing here.
Okay, got it, sir.
Yeah. So see here, even though in the R0, I'm representing R0 is just 0x1, but it is 0x0001 2 bits. But when I make not, even higher bit has some value, right? FF. That's why I'm showing that also, because higher bits are
So,
not
what is
0.
F? F, it's
F stands for
false.
15.
Oh, okay.
So F. And what is this? 1110. That is E. Got it?
Yes, sir. Yeah. Okay. So, sir, if in the place of the third F, if there was 1010, we would have written FFAE.
Correct.
Okay.
So finally, we have move R1, R0, left shift logically hash 31. What will be the value of R1, R0?
So 31 first we gotta represent it in bits and
No. This is, I'm saying R0, what value it has? This E, right?
oh yes, sir.
R0 has this value. So I have
So
to
won't
left shift.
then just 0 be just 1 will be stored in R1 because it contains 32 bits. If 31 bits are left shifted,
Then actually it stores 0 only, because last 0th bit is 0, right? So I will, if I shift this to this position, so everything will be shifted out 31 bits, because after making not, it became FFFFE, right? Everything will become 0 now, R1. Correct.
so
So
but
this is
why
actually,
isn't
if
the
I,
FFF considered just by shifting?
no, actually when I
Why
say
isn't this?
when I'm
Yes, sir.
shifting left, so I'm actually moving this last bit one by one, right? So it will, if I left shift 1, so it will become just like 1110 2, it will become 1100 because I added one more 0. So if I keep shifting like this, everything will become 0. I mean, this MSB will keep going out. Correct? Last bit I have to remove.
Yes.
Last bit I have to remove. So finally, only 0 will, this 0 bit will remain because 0 bit will come here, but all MSB are appended with zeros. Right?
Yes, sir.
Getting right?
Yes, sir. Yes, sir.
Yeah. But R1, see, this is actually, this is R1 updated. R1 means 0. But R0 still is FFFE only. R0 did not modify. This will not touch. So only R1 is, so what I am saying, so I'll left shift R0 value with 31 and then I will store with R1. But I'm not changing R0. Okay, R0 will be still FFFF, FFFE. Got it,
Got
na?
it, sir. Yes, sir.
Yeah. Same way, if I tell move R2, R0, left shift logical #2. What will be the value of R2?
So the value of R0 is still the same, like.
Yes, it is
So is
FFFE,
it the
right?
zeros? Oh, FFFE. Okay. So it will be then FFFF without the last two FE.
Yeah,
So it will be FE.
FFFF and FF. F will be as it is. E is actually 1110. But now I am shifting twice, right? So this
Yes,
also
sir.
will become 0. This also will become 0. Correct?
Oh, yeah, sir.
So it will become FFFF8.
So
Got
it's
it,
a
na?
little hard with too many digits.
But but actually we can't do anything,
It
right?
was
So it's like,
easier with the above examples and everything.
yes. So I mean, if you solve this easily, you can what do you say? Understand the other thing, right?
So, but most questions are asked as the 32 bits or the above one.
Anything they can ask. Actually. I mean, even 32 bit also they can ask. Because this example what I'm taking, it is from the notes what you shared itself.
Oh, okay, sir.
This example they have given in your notes. That's why like I wanted to solve this 32 bits.
Yes, sir.
Okay. I think this meeting will end. This is 40 minutes, right? Usually it's in Zoom free call. So tomorrow we will discuss other instructions. Okay.
Yes, sir. Okay. So tomorrow is starting from rotation because today shifting is done.
Yes. Tomorrow we will discuss on rotations.
Okay, sir. Sir, and tomorrow can you please take a few more examples about the 32 long one?
Yeah. Sure.
Okay, sir.
Okay. Thank you.
Yes. Thank you, sir.
Also, I'll upload the video and share it with the link.
Yes, sir.
Okay. Thanks.
Okay. Thank you, sir.